Italy's most active volcano, Mount Etna, once again erupted, billowing a thick plume of smoke and ash into the Sicilian sky. Scientists have warned aviation authorities of a potential risk for air travel.
In the deep waters east of Sicily's coast, a fisherman felt his hull judder with a force he couldn't explain. These were not the familiar tremors of Mount Etna's countless eruptions, nor the gusty turbulence of a Mediterranean storm. What he sensed instead was an ancient mass in motion, a shudder in the very roots of Europe's most powerful volcano. Unbeknownst to him and to the sleeping city of Catania, Etna's massive southeastern flank was beginning to slip even further toward the sea, at a rate faster than any seen in recent history, a seismic event, invisible at the surface, yet colossal beneath the waves. For centuries, Sicilians have lived under Etna's shadow, but now, for the first time, the mountain's persistent, silent slide has triggered an existential alarm, the threat of sudden collapse and an unleashed tsunami. Across the globe, headlines blare of Etna's latest eruption, lava fountains painting the night sky, ash grounding flights from Palermo to Paris. But as spectacular as these surface displays are, what lies beneath is far more ominous. New, independently verified geological data, sourced from both German and Italian seafloor monitors, reveals that a vast slab of Etna, weighing billions of tons, has begun to subtly but steadily ease toward the Mediterranean. It's not just the world's most active volcano, it is now a geological force in retreat. Major European newswires, ANSA, Reuters, Focus Italia, detail how this creeping collapse is taking place under the sea, extending the destabilization for kilometers offshore. It is an unstoppable contest between stone, gravity, and time. As one expert, Dr. Morelia Ulab, told La Repubblica, we cannot exclude flank movement evolving into catastrophic collapse. Yet the reality, when stripped of scientific detachment, is more sobering still. We are witnessing a process that could, in a worst-case scenario, transform Mediterranean coastlines in minutes. A threat that doesn't erupt, but simply slides. If Mount Etna's submerged flank were to fail, as data suggest is within the realm of possibility, every village and city from the Ionian coast to much of Catania's plain could face a rapidly rising sea, not in centuries, but in the blink of a geological eye. How much longer do people living in Etna's shadow truly have? And why, of all the mountain's legendary dangers, is this silent slip now the one scientists most fear? What, in the careful words of one volcanologist, are we missing about the true power and fragility of the ground beneath our feet? For the answer, we must look beyond the lava, into a world where even bedrock can move. From afar, Mount Etna appears as Europe's mightiest volcano, a 2-mile-high colossus, forged by floods of molten rock and sculpted by countless eruptions. For thousands of years, its peak has been a spectacle of fire and fury for all Sicily to see. Yet, rarely does public attention focus on the growing instability beneath Etna's slopes. Recent research has brought a different kind of drama, measured not in eruptions, but in millimeters, a creeping, relentless slide of the entire southeastern side toward the sea. Geologists have long studied Etna's peculiar geography. Formed where the African and Eurasian tectonic plates meet, the mountain sits above a restless subduction zone, a landscape that is, quite literally, always in motion. But what researchers did not fully appreciate until the deployment of advanced submarine sensors was just how much of Etna's submarine base was already moving. Teams led by Dr. Morelia Ulab and Dr. John Murray, whose work has been published in Italian scientific journals and covered by outlets like National Geographic, have tracked this shift in stunning detail using ocean floor transponders. These instruments confirmed that the flank is not simply wobbling due to eruptions overhead, but is instead sliding as sediment and volcanic rock give way, succumbing to gravity's steady pull. The latest figures are concerning. Satellite radar and undersea stations confirm that, in some places, the mountain's flanks move by several centimeters within a single month. Since long-term monitoring began, major blocks have shifted by more than 4 meters. As Dr. Ulab stated during a 2023 symposium at the Italian National Institute of Geophysics, Etna's submarine slip is ongoing and may be accelerating. What's often missed in headlines is this: Etna's ultimate collapse would not start with a spectacular explosion, but with a deep water fracture, silent and unseen. In May 2017, for example, sensors detected a 4-centimeter slip across a fault in just 8 days, equivalent in energy release to a magnitude 5 earthquake, yet without a noticeable tremor above ground. The fact that such changes can occur invisibly above is precisely what alarms scientists. If Etna's hidden weaknesses can shift so quietly, how can any early alert system possibly provide adequate warning? For a moment, consider this unsettling mystery. How can Europe's most closely watched volcano be primed to fail while the world fixates almost exclusively on its eruptions? To understand the risks now facing Sicily, we need to look back, not merely decades, but thousands of years into Etna's deep geological history. Beneath its slopes, where scientists have drilled deep core samples, lie records of disaster, layers of submarine debris, volcanic ash, and displaced ancient landscapes. Each stratum, excavated and analysed by multinational teams, offers evidence not of gradual weathering, but of cataclysmic landslides. The scars left by such events are visible even from orbit. The Valle del Bove, a 4-kilometer wide horseshoe gouged into Etna's eastern side about 7,600 years ago, is the mark of an ancient mega-collapse. Geological maps, backed by high-resolution sonar scans, trace the associated debris field more than 25 kilometers offshore, a mass of displaced rock on a staggering scale. Dr. Julia Crummey's paleomagnetic studies, widely referenced in scientific literature, point to a recurring pattern. Megacollapses at Etna are not flukes, but historically repeated events, separated by intervals ranging from 10,000 to 8,000 years. And, as the most recent interval now exceeds those previous, Etna is, as Dr. Crummey cautions, overdue on geological timescales. There is one aspect so often underestimated. Even as Etna's eruption frequency increases, so too does the risk of structural failure. Historical records compiled by Italian civil protection agencies show this progression. The infamous eruption of 1669 sent lava flows that permanently altered the coastline, while more recent flank movements in 1928, 1981, and 1991 have highlighted growing instability. Yet, none of these were as insidious as the quiet, sustained movement now recorded beneath the Ionian Sea. What scientists have learned is chilling. Etna's worst collapses have always come after periods marked by both elevated volcanic activity and silent, steady slippage between eruptions. In other words, Etna often foreshadows its deepest threats, not with loud signals, but with subtle patterns only recently deciphered. If you want deeper explanations and updates grounded in scientific fact, make sure you subscribe now. By joining, you'll stay ahead of these ground-shaking discoveries as this ongoing story evolves. So what does it really mean when the record of the Earth itself warns us that collapse is not only possible, but probable on a long enough timeline? Mountains do not fall the way we imagine. For generations, the classic signs of volcanic catastrophe included the roar of rising magma, tremors beneath our feet, and billowing clouds of gas. Yet Mount Etna is rewriting the rules. According to research published in recent years by both Italian and German teams, the instigating force here isn't volcanic activity at all. It is gravity at work on a grand scale. A massive block of stone, estimated at over 100 billion tons, is slowly detaching from the main body of the volcano and moving toward the sea. Subsurface imaging reveals that Etna's southeastern flank is effectively a coherent block, with its movement speed increasing the closer one gets to the water. Like a massive stone shelf whose supports are dissolving, the block is less and less held together by Etna's core strength. After years of water infiltration and repeated earthquakes and eruptions, the undersea faults have grown slick, triggering a relentless, creeping slide. As Dr. Raphael Paris, Université Clermont-Auvergne, has commented, it's as if the mountain is unbuilding itself from the ground up. What might trigger the final failure? According to National Geographic and ongoing scientific debate, Etna's slippage is difficult to predict. It may not even require an eruption to set disaster in motion. Sudden acceleration is possible due to submarine landslides or the collapse of weak sediments. Traditional early warning systems designed for earthquakes or eruptions are of limited use here. There may be only hours, or even less, between a spike in flank movement and catastrophe. In past monitoring, the shift from slow creep to sudden slip has happened within days, and no surface signal gave much warning. Computer simulations run by Dr. Paris and his colleagues, referenced in both Italian and European scientific reviews, offer sobering estimates. If the entire unstable block of Etna's eastern flank were to fail at once, a low probability, high impact scenario, a mass of rock equivalent to one of the worst prehistoric landslides would plunge into the Mediterranean, displacing enough water to create an initial wave tens to more than 100 meters high. In 10 minutes, tsunami waves could batter the Sicilian coast and impact neighboring regions. Even the failure of a much smaller portion, 10 to 20% of the mass, would likely result in waves capable of devastating coastal communities. This presents an urgent question. Has modern science, despite all its advances, truly prepared us for a disaster that may unfold without significant warning? Today, over 1 million people live close to Etna, in towns and cities nestled on its fertile slopes. Places like Zafferana, Chiare, and Via Grande. These communities, as acknowledged by Italy's Civil Protection Agency and reported by ANSA and La Stampa, are uniquely vulnerable. Days ago, a 4-kilometer landslide near Nisgemi forced thousands to evacuate. While it was not directly linked to Etna's main slide, it served as a grim reminder of how fragile Sicily's ground can be. But the nightmare event, Etna's submarine flank collapsing, would make swift evacuation nearly impossible. The region's main arterial roads twist through mountainous terrain, and even the best managed drills face immense logistical challenges. In realistic scenarios, tsunami waves triggered by a collapse could reach the Sicilian coast within minutes, while Malta and parts of southern Italy would be struck soon after. Within an hour, major population centres around the eastern Mediterranean could be impacted. The economic aftermath would be profound. Reports from the European Commission's Joint Research Centre warn of devastation to ports, refineries, transportation infrastructure, and more. Tens of thousands could be left homeless. Local economies could grind to a halt, and emergency services would be overwhelmed. The loss would not just be in buildings or roads, but in years, cultures, and identities. A profound wound to Sicily and its neighbours. This forces a sobering calculation. How do you evacuate entire cities if the warning comes late or not at all? What does meaningful preparation look like when time is so short? If you find these insights into Etna's deeper dangers and their human implications valuable, please subscribe now. Our investigative team brings carefully sourced, up-to-date information designed to keep you informed about the forces shaping our planet. In recent years, monitoring of Etna's movement has become a global scientific priority. International teams, publishing in Science, Nature, and other major journals, and Italian networks like the INGV now maintain dense arrays of sensors, both on land and below the sea. These monitor slippage, seismicity, gas emissions, and satellite radar profiles in real time. Yet, the limits of this surveillance are sobering. Scientists, led by Dr. Ulab, have tracked slow, steady shifts for years. But the critical moment, the transition from gradual drift to catastrophic collapse, may occur too quickly for alarms to be meaningful. Recent presentations at the International Volcanology Congress acknowledged that in the case of submarine flanks, no robust and reliable warning signal has yet been found. Nevertheless, Sicily and the wider Mediterranean have not stood idle. Civil protection exercises are now routine in Catania and coastal villages, and new evacuation route signage has been mandated. Crisis response plans drafted in collaboration with European Union agencies are regularly updated in light of new findings, and tsunami readiness training is incorporated into some school safety protocols. Still, the uncomfortable truth lingers. With unpredictable events like Etna's slide, even the best preparation may only buy time. The real challenge is not just technical, but also psychological, learning to live with risk that is, by its very nature, hidden until the critical moment. The ongoing observation of Etna carries an urgent lesson, not just for Sicily, but for all coastal populations living atop unstable geology. Other volcanoes, such as Stromboli, Vesuvius, and distant peaks in the Pacific, share the risk of sudden flank collapse. The same slow, relentless forces operate wherever mountains meet the sea, and setbacks in prediction or emergency response here may translate into similar vulnerabilities elsewhere. Governments across Europe and the Mediterranean are beginning to respond. The European Union, via its Joint Research Centre, is funding new models to anticipate volcanic tsunami risks across the region. Italian civil protection repeatedly updates hazard maps, and lessons learned in Japan, New Zealand, and the US are being adapted in real time to the Mediterranean. In Sicilian schools, tsunami evacuation drills are spreading, and scientific networks are growing in scope and data sharing. Yet, as Dr. John Murray has observed, we are all, in a sense, living on the slopes of Etna. The phrase is both metaphor and warning, underscoring the shared vulnerability of all who live on unstable ground, often without fully realizing it. As this story reaches you, satellite sensors, submarine monitors, and hazard networks remain focused on Etna's shifting form. Each new measurement tightens the spiral of uncertainty. For all our technological ingenuity, there is one fact no model can refute. The risk of catastrophic collapse grows with time, not just with each eruption. What does it mean to live on the edge of such vulnerability, on slopes that might, without much warning, become ocean floor? History demonstrates that all our preparation, though essential, may not guarantee certainty. Policymakers, scientists, and ordinary families alike must confront the same impossible dilemma. Sometimes, the most profound threats aren't those that announce themselves loudly, but the ones that advance quietly, inch by irreversible inch. Should Etna's flank give way tonight, tomorrow, or in 10 years, it would remake coastlines, communities, and lives, leaving behind a stark lesson about how fragile our solid ground truly is. So, as Sicily's greatest volcano moves ever closer to the abyss, one question endures. Are we truly prepared for disasters that arrive without warning? Can our science and our societies keep up with a world where the unthinkable may happen at any moment? If you rely on truth-based, thoroughly sourced reporting to make sense of the real dangers shaping our world, subscribe now to this channel. Let us know in the comments. Do you think world governments are truly prepared for a volcanic catastrophe on this scale? What steps should communities living in Etna's shadow take to be ready for what may come? And stay tuned for our next episode, where we'll bring you into the front lines of the scientific race to decipher the world's most mysterious disasters. Stay alert, stay curious, and remember, never take the ground beneath your feet for granted.